Hello students, I Mrs. Madhavi Mhatre welcome you all in the next lecture of Mathematics 1. I hope all of you are doing well at home. We are studying chapter number 5, Probability. And in this chapter, we have discussed all the topics, probability, the meaning of probability. Then we have seen what are random experiments and its outcome. Then we have seen sample space and event. And afterwards, we have seen probability of an event. Also, we have seen the formula for probability. Let's revise that formula once again. So, probability of the event means possibility of the expected event. It is expressed in number. So, in mathematics, it is called as probability. And then we saw the formula that here the if the random experiment is A and sample space is S, then the probability of the event A is written as P of A, and the formula for the probability of event A, that is P of A, is number of sample points in event A divided by number of sample points in the sample space, that is N of A divided by N of S. Now this probability is always expressed in the fraction or it is expressed in percentage. Now let's see the probabilities, how the probabilities properties are. Okay, so let's see the properties of probabilities. So here first thing we can say that the probability is expressed as a fraction or a percentage. Then the probability of the any event is from 0 to 1. That means probability cannot exceed 1. It cannot be negative. It is always from 0 to 1 or 0% to 100%. So if E is an any event, then the probability of that event is always greater than or equal to 0 and less than or equal to 1. Or in percentage, if we want to see, then here the probability is between 0% and 100%. Now, as we have seen, the probability can be expressed as a fraction. That means it can be written as 1 upon 4. This is fraction. And the same fraction we can convert to percentage. You know that when we multiply here by 100, then we get the probability as 25%. So the probability is either can be written as a fraction or it can be written in percentage. What you have to keep in mind is the probability cannot be less than 0 or it cannot be more than 1. It is always a number which is from 0 to 1. Okay. Now let us start with the last practice set 5.4. First question. If two coins are tossed, find the probability of the following events. First one, getting at least one head. Second, getting no head. Now when we solve the sum of probability, first we have to write down the event, its sample space and then a number of sample points in the sample space. Then we need to write event, then number of sample points in that event, and then by using the formula we have to find probability. Okay, so first of all write down the event as a statement that two coins are tossed. Okay, write it from the question only, that if two coins are tossed simultaneously, then the sample space S is HH, HT, TH and TT. Okay, so these are the four sample points, and from this we can write down N of S as 4. Now take the first event, that write down, let A be the event of getting at least one head. Okay, or you can write this way also, condition for event A, getting at least one head. You need to describe the event. Don't write the event directly. Afterwards, you have to write down that event in the form of set. And for that, you are going to use the sample points from the sample space. Now, at least one head means what? Minimum one head means more than one also is allowed. Two heads are also allowed. So in set A, we have sample points HH, HT and TH. And therefore, N of A is 3. Number of sample points in event A are 3. Now from this, we can write down probability of event A as P of A is equal to N of A upon N of S. That is 3 upon 4. Writing formula is compulsory. Every time you need to write down the formula. Okay, so here now we have expressed the probability in the fractional form. There is no need to express it into the decimal form. You have to keep it as it is. Now let us see what is event B. So write down condition for event B is getting no head. No head means only tail. Okay. So here we have only one sample point in set B, that is TT, and from that we can write down N of B is equal to 1. Then we have to find out probability here, that is P of B is equal to N of B upon N of S, that is 1 upon 4. Okay. So in this way you are going to solve the question. I hope you must have completed it. If not, you can pause the video and you can write it. Now I am going towards the next question. Question number 2. If two dice are rolled simultaneously, find the probability of the following events. The sum of the digits on the upper faces is at least 10. The sum of the digits on the upper faces is 33. The digit on the first die is greater than the digit on the second die. Okay, so here we are provided with 3 events. So in the solution, first we have to write down the given experiment, that the two fair dice or two dice are rolled simultaneously, and from that we have to write down sample space. We have discussed this sample space previously also. As I have said, you have to write this sample space by using 6 lines like this: 1 1 1 2 up to 1 6, then 2 1 to 2 6, 3 1 to 3 6, 4 1 to 4 6, 5 1 to 5 6, and 6 1 to 6 6. Okay, the brace bracket should be at the beginning of the first line and at the end of the last line, and then write down the number of sample points. N of S is 36. Now let's go towards first event or event A. The sum of the digits on the upper faces is at least 10. At least 10 means minimum 10, 10 or more than 10. So what we can observe here is the minimum sum is 2, 1 plus 1, 2. And the maximum sum is 6 plus 6, 12. So here the possible sums are 10, 11 and 12. So we have to write down all the sample points where the sum is 10, 11 or 12. So see here, first line, second line, third line, no sample point will come, because here you will find that maximum sum here is 7, here it is 8, here it is 9, but we want 10 or more than 10. So the first sample point here will be 4 6, because 4 plus 6 is 10. Then here we have 5 5, 5 6, and here we have 6 4, 6 5 and 6 6. Okay, so all these sample points we have to write down as event A. Okay, so let us write down event A. The sum of the digits on the upper faces is at least 10. So therefore A is equal to all these sample points as I have discussed just now: 4 6, 5 5, 5 6, 6 4, 6 5 and 6 6. So from that we can write down N of A is 6, and therefore P of A is N of A upon N of S, that is 6 upon 36, which we can write as 1 upon 6. Then event B. The sum of the digits on the upper faces is 33. Now while discussing this event A, I told that the maximum possible sum here is 6 plus 6, 12. More than 12 we cannot get. So we can say that this is an impossible event. And therefore B is a empty space here, or empty set here, null set here. And therefore we can write down N of B is 0. And from that, P of B we can write as N of B upon N of S, that is 0 upon 36 is equal to 0. Then third event, which we are writing as event C, the digit on the first die is greater than the digit on the second die. Okay, so think that in the first line we were having 1, 1, 1, 2 and so on. So there the digit on the first die was not bigger. So we have to come to second line, and from that we will write only one sample point, that is 2, 1. Then from third line 3, 1 and 3, 2. Then from fourth line 3 points, 4, 1, 4, 2, 4, 3. Then from fifth line 5, 1, 5, 2, 5, 3, 5, 4. And from the last line 6, 1, 6, 2, 6, 3, 6, 4 and 6, 5. See, everywhere the first number is greater than the second one. So here in all we have 15 sample points. And from that we can write down probability of event C, that is P of C is equal to N of C upon N of S as 15 upon 36. And further we can reduce it to 5 upon 12. We can divide both the places by 3 and we have to write down here. Now see, it is in ratio, so always you need to reduce it to the lowest form or the smallest form. Okay, so in this way we are going to write probabilities. Now let's go towards the next question. Question number 3 here. There are 15 tickets in a box, each bearing one of the numbers from 1 to 15. One ticket is drawn at random from the box. Find the probability of event that the ticket drawn shows an even number. Second, shows a number which is multiple of 5. Okay. Now let's start with the solution here. So write down what is the experiment here. The experiment is what? There are 15 tickets in a box bearing one of the numbers 1 to 15. So from this we can write down the sample space as all the numbers from 1 to 15. Okay, here I have written all the numbers, but as I have said, you can write down some numbers and then you can put dot 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 and you can write the last number also. Okay, but here 15 numbers were there, so all the numbers are written here. We can write here now that N of S is 15. Now let's see the first event, that here the card shows an even number. So describe it as event A, that let event A be the event that the ticket drawn shows an even number. So here we have to write down all the even numbers 2, 4, 6, 8 and so on. So here you write down all the even numbers 2, 4, 6, 8, 10, 12, 14. Now see, here you can miss the numbers, or if you skip the numbers it will do. But while writing the sample space here for the event, that time you have to write down all the numbers. All the sample points you need to write down in event 2, 4, 6, 8, 10, 12 and 14. Okay, so here we have 7 sample points in this particular event. So N of A is 7. Now from this we can write down probability of this event as P of A is equal to N of A upon N of S, that is 7 upon 15. Now let's go towards the second event and let us describe it as event B, that let B be the event that the ticket drawn shows a number which is a multiple of 5. Okay. So event B, the ticket drawn shows a number which is a multiple of 5. So we can write down this set B as 5, 10 and 15. Only 3 sample points will come in event B because we have to write it from the sample space. So there we have numbers from 1 to 15, and from that only these 3 numbers 5, 10 and 15, they are multiples of 5. So B contains these 3 elements and therefore we can say that N of B is 3. Now from this we can write down probability of this event, that is P of B is equal to N of A upon N of S, that is 3 upon 15 is equal to 1 upon 5. Okay. Always write it in the lowest form. Now let us go ahead. Question number 4. A two-digit number is formed with digits 2, 3, 5, 7, and 9 without repetition. What is the probability that the number formed is an odd number and a multiple of 5? Now this question you will solve as homework because such one solved example we have discussed, and in the previous exercise or practice set we have seen how to write down the sample space and events there. So here you have to frame two-digit numbers without repetition. So the first number will be 23, then 25, 27 and 29. Then you can write down the numbers with 3 at tens place as 32, 35, 37 and 39. 33, 22, 55 they are not allowed without repetition. So you can write down all these numbers, and from that you can write down n of s, that means number of sample points. Then you can write down the event a as the number formed is odd number, and then you can write down the event and you can get the probability. Similarly you can do for the second event, that is event b, that the number is multiple of 5. Okay, so please solve it as homework. Now let us go ahead. Question number 5. A card is drawn at random from a pack of well shuffled 52 playing cards. Find the probability that the card drawn is an ace, and second event is a spade. So first of all you have to write down the event or the random experiment, that a card is drawn from the pack of well shuffled 52 playing cards, and therefore directly you have to write down number of sample points. I told you that in case of these playing cards experiment you need not write sample space there. It is too big also, and here you know that while writing the set repetition is not allowed, and already they have given 52 playing cards are there, so there is no need to write down the sample space. Directly you can write down that number of sample points n of s here is 52. Now let's go towards the first event, that the card drawn is an ace. So you have to take that as event a, that the card drawn is ace. You know that ace we call ekka. When we play the cards, that time we say it as ekka. Ace is called as ekka. It is neither number card nor a face card. And then we have four types of cards: diamond, spade, club and hearts. So we have four ace there of each type. So four aces are there, so we can write down n of a as 4. And from that p of a we can write as n of a upon n of s, that is 4 upon 52, which we can reduce to 1 upon 13. Okay, so this is the probability that the card drawn is an s. Now let's go towards the second event, that event b is the event that the card drawn is a spade. Now we know that 13 cards are there of each type, so here for spade also we have 13 cards. So n of b is 13, and from that we can write down probability of event b, that is the card drawn is a spade, is n of b upon n of s, that is 13 upon 52, which we can reduce to 1 upon 4. Okay, so in this way solving these sums is very easy. If you know how to write down it properly, then you are going to get full marks for these particular sums. Okay, now let's go ahead. So practice sets are finished. Now we will start with problem set. And you know that in problem set the first question is always of MCQs, multiple choice questions. So here let us start solving MCQs. Choose the correct alternative answer for each of the following questions. Now see here in this chapter what we have to keep in mind is the probability of the event is always from 0 to 1. Then the formula for probability P of A is equal to N of A upon N of S. Then you must know the how to write down the sample spaces for all the random experiments which are described here. So let us start now with the first MCQ. Which number cannot represent probability? So just now I told you that the probability is always from 0 to 1, or it is between 0% to 100%. So see, 2 upon 3, it is less than 1. 15% is between 0 to 100. 0.7 is also less than 1. Only this 1.5, this is greater than 1, which is not possible in case of probability. So we can say that this option B, it does not represent probability. 1.5 does not represent probability. Okay, so writing this answer is very easy. Now let us go towards the second sum. A die is rolled. A die is rolled means how many sample points we have? 6. 1, 2, 3, 4, 5 and 6. Okay, 6 on 6 faces. What is the probability that the number appearing on the upper face is less than 3? Less than 3 means 3 is not allowed. So the number should be either 1 or 2. So only 2 sample points are there in this particular event. So 2 upon 6, that will be what? 1 upon 3. So here the probability is what? 1 upon 3. So option B is the correct option. Now third question here. What is the probability of the event that the number chosen from 1 to 100 is a prime number? Now in 7th standard, in 6th standard, you have studied about prime numbers. And there you have found out all the prime numbers from 1 to 100. So if you can recall that from 1 to 100 we have 25 prime numbers. Okay, so here n of a is 25 and numbers are from 1 to 100 means n of s is 100. So the probability here is 25 upon 100, that is 1 upon 4. So option C is the correct option here. Okay, but here you must know that there are 25 prime numbers from 1 to 100. Okay, now let's go ahead towards the next one. Fourth MCQ here. There are 40 cards in a bag. Each bears a number from 1 to 40. That means here number of sample points are 40. N of S is 40. One card is drawn at a random. What is the probability that the card bears a number which is multiple of 5? Okay, so from 1 to 40, how many multiples of 5 are there? Say table of 5. 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25, 5 six are 30, 5 sevens are 35 and 5 eights are 40. So from 1 to 40, we have 8 multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40. Okay, so 8 numbers are there. So n of a is 8 and n of s is 40. So 8 upon 40, that is 1 upon 5. We can reduce it to lowest form as 1 upon 5. So here the correct answer is option A. Okay. Now let's go towards the last MCQ here. If n of a is 2 and p of a is 1 upon 5, then n of s is question mark. What is the n of s? So make use of the formula of p of a. P of a is n of a upon n of s. Okay. So that means here this is the lowest form of n of a upon n of s. Okay. So here to get 2, if we are multiplying by 2 here, here also we need to multiply by 2. So 5 twos are 10. So value of n of s is 10. Okay. There are 10 sample points here. This way you are going to find out the answer. Or simply you can make use of the formula and then you can write down n of s is n of a upon p of a, that will be 2 into 5, 10. Anyhow you can solve it. Okay, now let's go towards the next question from problem set. Question number 2 here. Basketball players John, Wasim, Akash were practicing the ball drop in the basket. The probabilities of success for John, Wasim, and Akash are 4 upon 5, 0.83, and 58% respectively. Who had the greatest probability of success? Okay, now here already the probabilities are given, but they are in different forms. See, here you have it is in fractional form, that means numerator denominator form. Here you have decimal form, and here you have percentage. So you have to convert them into at least one form. Either you convert all of them in decimal fractions, or you convert all of them in percentage, your choice, and then you can compare. Okay. So here what I am doing is I am converting them all into the decimal fractions. Okay, so what I am doing is the probability that the ball is dropped in the basket by the John is what, 4 upon 5. I am going for actual division, then I am getting the answer as 0.80. We are getting 0.8, but here two decimal places are there, so I wrote it as 0.80. If I want to convert it into percentage, then I should multiply here by 100, and then I can convert into percentage. Your choice, you can convert in any, like I am converting here into decimal fractions. Now second one, the probability that the ball is dropped in the basket by Wasim is 0.83. It is already given in the question. And for Akash it is 58%. So 58% is nothing but what, 58 upon 100, that is 0.58. Now see, all the possibilities were converted in decimal points. Now can we compare that which is the highest number here? So we can say that here 0.83 is the biggest number. So we can say that here the Wasim has the greatest possibility of success by comparing like this. Now, as I am telling you that it is your choice, you can convert it to the decimal fraction, or you can convert it into percentage also. You know that to convert into percentage means to simply multiply by 100. So you can do that also for the first one and second one. So here if you convert into percentage, 4 upon 5, if you multiply by 100, you will get 80%. And here if you multiply by 100, here you will get 83%, and this is already in percentage. So then also you will get the same answer, that Wasim is having the greatest probability of the success. Okay. So this was a simple question of 1 mark. Now let's go ahead. Question number 3. In a hockey team, there are 6 defenders, 4 offenders, and 1 goalie. Out of these, one player is to be selected randomly as a captain. Find the probability of the selection that the goalie will be selected, and second event, a defender will be selected. So first of all, you can write down the number of sample points here, that is n of s. Okay, that the total number of players in the hockey team are how many? 6 defenders plus 4 offenders plus 1 goalie, that is 11. So we can write down n of s is 11. You know, in this case here, you cannot write down that sample space as a set. If you want, you can write, but then you have to take defenders as D1, D2, D3, D4, D5, D6. That will be complicated, and it is not compulsory also to write down the sample space there in the form of set. Only you describe it and you write down the correct number of sample points. Okay, so here n of s is 11. Now let us take the first event, that the goalie will be selected as a captain. That let A be the event that the captain selected will be a goalie. So now here there is only one goalie in the hockey team, and therefore here n of A is 1. And therefore probability that the captain is a goalie is 1 upon 11, because the formula is what? P of A is equal to n of A upon n of S, that is 1 upon 11. Then the second one, a defender will be selected. So see how many defenders are there? 6 defenders are there. So you can write down there are 6 defenders and therefore here n of b will be 6. Okay, so let us see. So let B be the event that the captain selected will be a defender. So there are 6 defenders in the hockey team and therefore n of B is 6. And from that we can write down P of B as n of B upon n of S, that is 6 upon 11. Okay. In this way you try to solve the remaining sums also from the problem set. And of course I am going to discuss them in the next lecture, so that time you can cross check your answers. Okay, but as a practice you can solve them by yourself. Okay students, so today I am stopping here. We will meet in next lecture. Till that, you stay home, stay safe, take care of yourself. Thank you students.